In the following tutorial, we will cover particle systems. There are a variety of applications for particle systems in the editor. For example, they could be used to draw the smoke from a chimney or to simulate the dust kicked up by the tires of a vehicle. Or they could be used to model droplets of liquid as you spray fertilizer. It can also be applied for unloading processes, whether it's the discharge from the threshing machine or debris from the wood chopper falling into a trailer. Let's take a look at how the particle systems work and how we can apply them in the Giants editor. Firstly, the adaptation of the basic shape of the surface from which the particles are emitted. Secondly, setting the properties of the particles, in particular their physical properties, as well as the number emitted. But before we begin, we need to download the sample files. As always, you can find a link to download them below the video player. Once downloaded, we then copy the archive of the download onto the desktop and unzip it there. Now we simply open the file crampy bbs900 site dps i3d to get an overview. Then open the first particle system and select the underlying p-plane shape 2 object. This object gives the shape of the surface the particles are emitted from. In the menu Create Light, let us create a light source to help us see the scene better. Once we're satisfied with our particle settings, we want to remove the light source, otherwise it will show up when the particle system is used in the game. First, we need to import a new shape in the i3d file by clicking on File, Import in the menu. We then select the file we want and click Open, in this case flat_2x2 i3d. Now that we have a new shape in the i3d file, we should save the scene by going to the menu and click File, Save. In the status bar, we can see the save has been completed. Next, we open the crampy bbs900 site dps i3d file with Notepad++. The last entry in the scene container is the file we just imported. We can then copy this line into the particle system container. Now we just need to copy the value for node ID and input it into the particle system under Emitter Shape Node ID. Then we simply need to save the changes in Notepad++ and switch back to the Giants editor. By clicking here, we can reload the edited i3d file. If we now press play, we can see how the dust is emitted from the new shape. The last step is to now make the shape invisible. To do this, we switch to the Shape tab and click the Non-Renderable checkbox. Of course, we can now delete the old shape, and then save the file with the Giants editor. Now let's move on to the properties of the particle systems. First, we need to open the window for the particle systems. This can be found in the menu under Window, Particle System. Now we'll simply go through the entire list of properties from top to bottom. The properties are divided into 3 subsections: Simulation, Spawn, and Rendering. We'll start with Simulation. First, we have the maximum number of particles that can be shown on screen at once. Bear in mind that this value only affects the current particle system though. Because of this, we need to be careful with the value we set. If we set it too high and there are multiple particle systems working at the same time, it could cause performance issues. Next, we have the lifespan of the particle. With this, we can set how long the individual particles are visible. Using the values of scale x and scale y, we can set the initial size of each particle. We can also increase and decrease the size of each particle in relation to their progressing lifespan by adjusting the scale x gain and scale y gain values. Next, we have 3 different settings for the rotation of the particles. First, the Rand Init Angle checkbox lets us give each particle a random rotation from the outset. The remaining 2 controls let us set the maximum rotation of each particle during their flight and over their entire lifespan. In other words, we can use these to set the rotational speed of each particle. Gravity fields play an important role in a particle system as they directly influence the flight path and characteristics of the particles being produced. By setting these three values, we can determine the forces that affect each individual particle. Now moving on to the next category, spawn. The settings in this section govern the initial movement of the particle directly after its creation. The first step is to set the emit rate, which dictates the rate at which new particles are created. This value works together with the settings for max particles and lifespan from the previous section to create a uniform particle beam. Ideally, you want to keep the rate as low as possible, producing the least number of particles you can in order to keep the strain on the graphics card and processor to a sustainable level. The speed value determines the speed the particles have when they are created. In some cases, though, not all of the particles should have the same speed. For these types of cases, another control called speed random can be used. Using this, you can set how much the speed should vary between the individual particles. The last two settings in the spawn section dictate the exit direction of the particles. For example, you can change the trajectory of the particle from a beam to a fan shape. The value for normal speed determines how closely the particles stick to the normal direction. In other words, how much they spread out during flight. We can even set the value of normal speed to a negative, sending the particles flying in the opposite direction. The tangent speed value indicates how strongly the particles are scattered. Now we come to the last category, rendering. In this, we can adjust the blend factor controller to set how transparent the particles are when drawn. And with a blend in time and blend out time, we can set how long the particles are visible for. As you can see below, we have the parameters texture atlas size and texture atlas size Y. These show how many subdivisions a texture uses. Usually these values are set to 1, as this is sufficient for most applications. We'll change that now though. For this, we will assign a different texture to the particle system. We select the emitter and then open the Material panel using Menu, Window, Material Editing. Then we can swap the diffuse texture for the potato particle point DDS file. Notice how the new file now has 4 horizontal subdivisions. Now that we have extra subdivisions, we need to alter our particle system to take advantage of them. We'll therefore set the controller for texture atlas size to 4. The particle system in the i3D file now assigns new particles randomly across all 4 areas of the texture, which results in a much greater optical variance. Now we come to the checkbox Z sorting feature. When activated, this allows you to sort the particles according to their depth, although we recommend leaving it switched off, as it increases the computational load significantly and is only really useful in a few exceptional cases. To finish off, we have a final tip to help you fine-tune your particle behavior. It is often the case that the particles are intended to closely follow a specific path along a vehicle and not stick to their physically correct trajectory. To combat this, we can set a user attribute to influence the behavior. So we can create a user attribute of the Boolean type with a name useWorldSpace in the particle system node. Setting it to true, we ensure the particles move with their physically correct acceleration when used in the game. However, if we set it to false, the particles are no longer affected by the gravity in the game, and instead behave as dictated by values defined in the particle system.